Hello and welcome back to another episode of Learning Rust with Git Oxide. This is Sebastian and my associate, Sid. Hello.
Thanks for having me.
In the last, and it's a pleasure to have you. I should learn to be polite on the show. It's this is the last thing that you saw, if you saw to the end of the last episode, which probably you didn't. What we did do though is to have our first struct here to practice how ownership and borrowing works with structs and if it's any different compared to what we did before with the ownership semantics of borrows. So this foo here right now, I think it doesn't have to be copy. It only has to be clone so that we are able to do this kind of thing. Let's remember, kung fu is a function that takes ownership of its parameter here. And this is why we have to do this dance with cloning x, because otherwise x is consumed on the first call and on the second. It's not there anymore. And that's why we have the squiggly red line. And I guess this summary is something you should do next time, because yeah, I don't want to talk all the time.
I would have said exactly the same.
I knew it. All right, then you're on next time. You do the summary. Thank you. Then I thought this session we could see what if we can get more complicated structs going here. This syntax is fine apparently. Let's see what happens if we do this. Is this fine too? Interesting. I mean, there's no syntax error here, but there is some red lines going on. Let's see what the compiler says. Okay, fair enough. So now I think this doesn't instantiate an X anymore. Now it does. So it's like it's interesting. It's like a function call, but it's not actually a function call. And we have the same issue, I think, that when we have foo moved into the first call. So to fix it, we should be able to clone like before. Okay. And it works. Interesting. So what's the difference exactly between this and this one?
Is there a difference? It doesn't look like one. I mean, it's still an empty struct.
Still no data in it. Except for, yeah, I mean, to me, semantically, it's kind of the same, even though now we already see where this syntax might be going, because it looks like an empty tuple. And now we just throw in the word tuple here. Probably most of you have heard about tuples. It's just a sequence of things of the same or of different type, a set of things that is known at compile time, most importantly. And that's an empty set. So there's nothing in it. This also means that if you wanted to, we could put stuff in it. And here in the declaration of the struct, we could just declare a type. Like, yeah, what should I put in there? Up to you.
Well, let's start with a string.
A string. The most complicated thing in Rust. Can you give me a primitive? Another primitive?
Fine. Then let's go with an I32.
I32. Nice. Also less to type. You know, I don't like typing. It's cold here. Okay, I32, that works. So now in order to get that instantiated, I can do this. Okay. What about this? It doesn't like that. But I could probably just add it here in the declaration. And now we have it's a bit like a named tuple. Right, so I could do this. Oh. And it's fine. So what is y now, you might ask? Like, what's the type of y? Because we have it fully inferred here.
Yeah, it's basically just the type of a tuple and two numbers, right? But named.
So how would I declare it if I wanted to be specific? Now I want to declare the type.
Yeah.
What's the syntax?
I think you would just write how you declare the foo struct, but without foo, right? So you essentially copy the same.
This. Yeah. It compiles. Great. So Rust seems to be quite consistent about its syntax. I like that for sure. Yeah, and that's it. So that's the difference. Named tuple versus anonymous tuple, unnamed tuple, however you want to call it. I don't know if that's the official name, by the way. It's just my name, I guess. Okay, cool. Semantically the same, nothing changes, so we don't have to practice the ownership and borrowing on this one. But now we have members, so it's a bit different. So what if I wanted to increment the I32 here? How do I do that? What's the syntax for this?
There you go.
Yep,
x.0 or x.1.
Exactly. That's IntelliJ, this is why this is the IntelliJ in IntelliJ, I guess. We can print it, we can do stuff with it. What about mutability? So if I assign to, if I try to assign it here, it says it doesn't work unless x is mutable. So mutability is transitive. And in order to get a mutable field of a struct, whether it's a named field or a tuple field, so it's just an index, the parent structure must be made mutable. So apparently there's no way to say, I want to have a kind of just one mutable field and the rest is immutable. No. It's either all or nothing when you have structs. And that might be interesting to work with. Okay. So this field here is copy. So we can't really see how move semantics work on fields. Because now in theory, I could get the idea to move a single field out of my structure. So I basically rip a piece out of my structure, so it's part of it is not there anymore. That could work now. I mean, I can do that. And I think there's something we could investigate. Okay. So if you wanted to investigate move semantics on fields, how would you do that?
Well, yeah, like you said, I mean, these types, like the I32 and U32, have the copy trait by default, right? So we would probably have to start out with a type that doesn't have it, like a string, perhaps, maybe. I don't know.
Okay, fine. Here you go. Here you have your string. And I just...
And then...
Yeah. And then... Okay.
Yeah, and then you would go ahead and try and move it out, right? Into another variable, maybe.
Okay. Into another variable. So we say y is x0. Okay. Now stuff gets squiggly. First of all, now with the string, it still works. And now if you put that in, it doesn't work anymore for both ones. Why is that? Borrow of partially moved value. Value borrowed here after partial move. Let's dissect this. Value partially moved here. So what is moved? What's the value that is moved?
Yeah, it is the first value of the tuple struct, right? So that is then being, the ownership is being moved into another variable. And that's, I guess, what the partial move means. It's not the entire thing, but just a part of it.
Yeah, not the entire structure moves like we did before all the time, but now just a part of it. Look at this. Part isn't partial. It's amazing. I mean, really, once you look really detailed and ask questions,
everything makes sense.
Everything makes sense. And okay, I think we got this one nailed. Now the next line. Value borrowed here after partial move. So it's interesting. One time, value partially moved here. What is value? Value must be x then, because here value is also x. Value partially moved. Okay, so it's more like a part of value x is moved here, and now it says x is borrowed here after the partial move. But why is x borrowed? Like, I don't see a borrow. Like, usually borrow is this, right? Or this. But why does it say it's borrowed? I don't get it. So the last one, the last message here, it says partial move of x0. Okay, that's good. Now we know exactly what it means. Partial move occurs because x0 is type string, which does not implement copy trait. So that's all we know already. Nothing new there. Okay, but now again, why is this borrowed? Okay, let's dig in. Let's use Command B to pardon, to dive in. Oh yeah, the clone implementation comes from here. Let's close this down. Look at how clone is implemented. It's a method on X, and it takes itself borrowed as a shared borrow.
So it's inferring the type here to be a borrowed value, right?
Yes. Yes. This is why, and this is where the borrowing comes from. So I think it's fair to say that in the moment something moves partially, you can't use it anymore. Like you can't use self anymore, can't use X anymore, because that's now incomplete. But also that's okay for Rust. Rust allows you to take apart these poor little structs and just leave them there, as long as you don't try to use the whole thing anymore, because that doesn't exist anymore. And that's.
So that means you could still use other parts of it though. So if you had a second string in the tuple, that you could still move out into a separate variable.
Let's try. Hello world to string. So it doesn't complain here. It seems to work. Same thing. Partial move. Okay. Which is interesting because now, I don't know, when I think about dissecting or taking apart structures, I thought what could be an actual useful application of this? Like when do you use that to your advantage? Because I've done that, of course, and I think it's worth noting, without going into too much detail, that it's quite common to have these structures and you take ownership of them, and then to make the usage of them easier, you destructure them. So in this case, I would say, okay, if I just have a tuple struct that doesn't have names, I would assign names to it, which are much better, obviously. Y and Z is so much better over 0 and 1, right? So much more descriptive. And then I could say x0, x1, like this. And it's exactly the same that we did before, but it's more typical, because this destructuring usually happens like that. And that's one way of doing it. Like I now create a manual tuple out of my tuple fields. And one could say, okay, but is this really how destructuring works? Is this the syntax? Like, is this how you do it with one of the more typical structures, which look like this? Like if you wanted to assign names, hello world. Oh yeah, let me do one thing. I keep hitting save and I expect it to format my code. I think this is something that can easily be set up here on Rust FMT, Rust FMT on save. And that's how I know it. Okay, that's better. Now, how would you destructure bar, for example? And how is the syntax for bar? And maybe we can make this better by looking at how destructuring this works. It's a bit of a digression to talk about destructuring, but I think it's really valuable to think of partial moves and when you use them, in terms of destructuring structures, because that's usually how I do it in practice. So here I already have field names, and it's kind of easier to think of a syntax that should preserve these field names. I don't want to do this and completely. So what do I not want to do? I don't want to do this. Let mut. Okay, let's just reassign this. Let x be bar. And now we have hello world like this. And now you see I'm able to do this. Like before, it's analogous to the tuple version here. And you see how wrong this looks, because now I'm essentially renaming the fields here, and I have to repeat myself. So if I wanted to have nice names here, you see I'm kind of tupling up individual fields of a structure and then destructure them with the tuple syntax. And even though that works and that's something you can do, it's not the best syntax for destructuring an actual structure. And that also shows here that this is, even though it's succinct or it's concise, it's short. It's just short because it's an example. Usually you wouldn't write this. So how's the syntax then? The syntax is, I think, quite consistent. Look how I declare the x here. If I want to destructure it, I'm doing this. Voila. And you see now that makes a little more sense. And I don't repeat myself. And if I forget a field, it will tell me. I can say I'm not interested in these fields and do this. And that exact syntax is used when matching structures too, which is something we definitely talk about in another episode. Which again leads to us saying Rust syntax is quite consistent and thus easier to learn. So with this in mind, with this syntax, yeah.
It's funny that the bar has to be there, that you actually have to explicitly say bar here, because it should be able to infer that, right, from the variable that you're passing on the right.
It should. So Rust is explicit. This also leads to funny situations where you kind of repeat yourself. For instance, if I do this in a function, I can have function bar foo, which takes an x. Which takes an x that is a bar. Okay. And now I can say, but I want to have the fields themselves and use them in the function here. Can I destructure that here right away? Yes, you can. Et voila. Now I've got access to hello and world and not access to the underlying structure. So I destructure that right away. But as you can see, it's kind of double, right? Bar, bar. And that would be nicer, I guess. I don't know, maybe there's an RFC somewhere in Rust that asked exactly for that as syntactic sugar or something. Maybe one day it happens, because many changes have been done since I started learning Rust that just made it more ergonomic. Because usually types are much longer and then it matters. For bar, it doesn't yet seem so bad. Okay, so how would I rewrite this to be the actual destructuring syntax for a foo?
Same way then, you would say let foo, and I would guess you would use parentheses instead of curly brackets, equals x, right?
Yes, so says IntelliJ. And it does compile, even though there is a ton of warnings for unused variables. What does it say again? It says is never used, unused, dead code. So here it tells you that the lint warn dead code is on by default. And I could say, for my, note the exclamation mark, oh, for my entire module here, I want to allow that code. And now you see, it's not talking about that code anymore. It's just talking about unused variables. So I could probably also, with the help of IntelliJ, say unused variables. And now that looks much better. And this unused mut is probably something that I want to actually remove now, because we don't do anything here anymore. But if you would, that would probably be here. Okay. So now we have this attribute again that I just throw in there. And the value of this is not to just silence the compiler, because these things, you should not actually allow them, right? But while developing, I do this. While developing, I say, okay, now I want to focus on a certain thing, and I don't want to care about unused variables. I don't want to care about certain things for a while. So I say this module is now Wild West, and I declare allow that code, unused variables, and other things that would otherwise be warnings. Because if there is a warning, it should be relevant to what I'm currently doing. And sometimes you're just sketching things. And that's the cool thing, that really Rust allows you. Rust has an opinion. Rust has a certain style and enforces it with a linter. You're using warnings, not errors, which is much better than errors. Like Go, for example, it gives you errors when it doesn't like certain things, even though it isn't actually an error. It's just somebody very, very opinionated. But Rust gives you warnings, which is right, but can be annoying. But you can also turn it off easily for a while. And then you turn it on again, you fix it as you progress towards more, let's say production code or typical code. Pretty neat. Okay, cool. So we have these two structures already. We have tuple structs, which certainly have their use, and the typical structs, which are named fields that have a certain type. And I can tell you that they behave exactly the same when it comes to partially moving them. Same thing. So means that X here, or let's say after this destructuring here, we can't use X anymore. And since we have now bar foo, we can try the same thing here. Bar foo X. And it doesn't like it because it's used. But here it does like it. But now it doesn't like that anymore because it's used. You are silent.
Yes, I'm just thinking about how you would then actually go ahead and solve that. So basically the next step of, okay, what if you do want to copy it out? Well, yes, okay, you can clone it explicitly.
Yes.
I mean, that's always an option.
Now they have to be cloned. Now they can't be copy anymore. I think we tried that last time because string is not copy. And the compiler doesn't just copy stuff for you. Even string is clone, obviously, because clone works. But it doesn't just call clone for you in order to copy things. No. If you do want that, by the way, you can implement this yourself. Like if you really want to break the rules, you are allowed to implement any kind of copy you want and do what has to be done. But the compiler won't do it for you. And that's fair. Yes, but same thing applies. Clone things in order to be able to do that. Or pass them by reference. So we just have this as a contrived example because usually you do pass references of the right type, either read-only or mutable. And that should be the default. Don't just pass ownership all the time. One more thing I think that's interesting here that I was just reusing X. How does it feel to you that X is foo here and it becomes bar here?
That is a little bit weird. to look at, but I'm guessing it's just kind of overriding the value and forgetting all about the original x, so to say.
Yeah, look at this. So
okay.
It's a new binding, a new let, and it indeed shadows the previous binding forever in this case. So
it goes out of scope once you basically redeclare the new x.
Yeah, let's say in this scope, which is denoted by the curly braces, x is now bar to the end of the scope. So in order to put that to the test, we should be able to say something like, let's remove the destructuring here so that we actually have an x. And now I'd like to do this and have it work. Because now it tells me that x is a bar, but it wants foo. But we know that x on top here is actually foo. So how can I make this, the binding of x, how can I make that temporary? Like how can I put that into its own scope?
Oh, yes, I think you can, right? Just wrap it in curly braces.
Wrap it in curly braces, because they are scopes. Okay. And now you see it doesn't show the squiggly line anymore. And it actually works. Nice. But this still does not work, because in this case, x would just be in the scope, because it's just there. It's not a separate thing, it's not a separate function. It's just a scope that inherits or sees everything in the outer scope, which makes sense. You want to keep using stuff.
And just seeing that, I have another question that I kind of stumbled upon. So if you were to say x equals and you make a new foo instead of the bar, that would work. And my intuition would have been that that would only work if you make the original x mutable. But it seems to be that doesn't seem to be the case. Even if you don't do the let, but just basically redeclare the old x.
It doesn't let you do it because it's an immutable variable. So IntelliJ allows you to fix that by making it mutable.
Okay.
I think I know what you're thinking. Maybe you can try to express that.
Does that have something to do with the default copy trait then? So if I try to do this with a default type, I'm not sure actually what's going on now.
Okay. So what are we doing? We are changing the memory that x points to something else. And that is actually visible after the scope. Like the scope is now, it doesn't matter. Let's try that, huh? Let's see what it is actually that we have here. We have hello world and we have hello scope here. And let's see what it actually is later. Yeah, let's clean up a bit. Wait, let's not endorse comments in code too much, or commented out code, which is probably worse. Then let's try to quickly print, or actually no, let's do what people should do. Let's debug x here, which is a macro that just prints x debug representation along with some information about where it is where you debug. You will see it in a moment. There's squiggly lines. I don't know why. Let's see what the details are. Foo cannot be formatted using this. So that's a format string. And that's how you say, I want a debug format of some argument. The trait debug is not implemented for foo. Look at this. Add derive debug. To foo or manually implement debug for foo It basically tells you what to do again, huh?
Too easy.
Too easy. Okay, as long as you read, it's actually helpful. Okay, we have foo here, and it says derive debug. Look, I really do it literally like it said. I just put a new derive here. And that works too, because it's really the same as if you would have said this, which is useful sometimes. Okay, and now we can run it, and it says hello scope. So as you can see, I've changed literally what was in this memory here to something new. And now with a let hello world. It makes sense.
Does make sense, yeah.
I was thinking maybe we can even get going with a few lifetimes here, because we can now play around with this and do things with borrowing and scopes and see what happens then. No problem. But I think we are at our 30-minute mark, which probably means we have to wrap it up gently. Okay, so what have we seen here? We have seen scopes in action, we have seen bindings, rebindings, and I think originally we came from, look at this reuse of the variable x and how that feels, and felt a bit odd because most languages don't actually allow you to do that. Like you can't, you're not supposed to shadow names. You're definitely not supposed to change the type of the name. Rust says do it to the point where it's actually endorsed and ultra common. And the reason for this is it's safe, it's fine, nothing can happen. You can't actually, I mean, I don't know what you can do wrongly with it, except for, I mean, look, what can go wrong? Now I made a mistake, so to say, but because by default things are immutable, I can't just accidentally override a value and then wonder why it's something else, right? It's Rust that makes this hard to misuse. Only if you happen to have this one mutable here and unintentionally happen to override it like this, then you would have a bug of some sort, because maybe that's not what you want. Maybe you want this. But then again, it's something like this kind of code with these scopes. You write that sometimes, but also, let's say in the real world, it's nothing that can be a foot gun for you. Not that I've ever run into this, and I run in every foot gun there is in every language. By default, that's what I do. I'm a foot gun finder. So yeah, very, very interesting how different semantics, different languages, stronger type systems can change everything, essentially. One more thing, if you put two debugs here, you see that, yeah, we actually have an X that is hello scope for a moment from line 22, and in line 25, we see another X, essentially, because this one is just shadowed in the scope here. Okay. And one more thing for fun, which might be a segue to what we do in the next session. And you see that also works. Oh no, wait. Actually, you see that it doesn't work because it printed, look, this line here is actually a tuple. This is an empty tuple that's unit. Let's learn this. This is unit because this is what would be null or nil in other languages. It's nothing. But it's not null, it's unit, which we know is zero sized. It's nothing. It's a tuple that has nothing in it. So yeah, nothing there. The problem here is the semicolon. Okay, interesting. So, right. Semicolon is a problem again. That was fun. So you see, semicolons have influence over what's considered an implicit return value. And if I remove this, main is returning something, even though it's not doing that, and it can't. I think it can't. Maybe it can. Yeah, I think it can't. I think it can return a result though, but we haven't done that yet. So this is why the semicolon says don't implicitly return anything. So now what's implied here is actually this. So this is what Rust does at the end of a function, so to say. Return unit if you don't specify anything. This is what that means. And that also works, as you can see. No red squiggly line. And what happens here is that we create a foo. It's implicitly returned in this scope that is surrounding it, which is itself an expression, which means it just passes on as a return value what's inside here. So scopes are expressions like any other. You see what you can do with that?
Yeah, so it's essentially like a function, right? Almost.
Yeah,
or like its own little scope that returns something at the end.
Yeah, it's a bit like that. And these things you use, I mean, I use them in practice to say, okay, I want to have something mutable for a moment, do stuff with it, usually hash maps, vectors, you initialize them, you push stuff onto them. But then you don't want to have that mutability hang around for too long. I want to restrict it to that scope because mutability is bad. And not that it can be abused because the borrow checker would tell you that something is not working, but I don't even want to see that. I want to see, I don't want to have mutable stuff usually. And this is why. You see me do this. And that does something with immutable y. Usually I go with very short variable names here, and then I assign it to something descriptive. And that's something that's really practical and useful, and that's how scopes can be used. And that's I think that's all that comes to mind when I think of scopes. Very important also for lifetimes later that we will also get to eventually, but let's see how long we can avoid them, because that's usually, that's a bit more painful for many, for sure. All right.
Right.
That is our today's sessions, 38 minutes. I hope you liked it. I hope you enjoyed the time.
I did. Thank you very much.
And I hope also the audience did. Thanks for watching, everybody, and see you next time for another session of Learning Rust. Bye-bye.